UFP, the United Federation of Podcasts.
Engage.
78 years have passed since the days of the original USS Enterprise. Now a new Galaxy Star ship has been designed.
Transporter Chief, beam our listeners aboard. Welcome to Galaxy Class, a Star Trek Next Generation podcast on the United Federation of Podcast Network. I am Chief Sofa Maker Joe Keegan, and joined with me today is Councillor Amy Nelson and Diplomatic Standard Bearer Kevin Scharf. Amy, how are you today?
Doing great. You gotta tell me and the listeners, sofa builder?
Oh, I'll show you a picture along with the picture of my log shed that I built. I built a giant garden sofa so somewhere to lounge in the sunshine. In the blistering
in what
heat,
little sunshine you have,
in the
yes.
blistering heat that we get in Scotland. So, yeah, I will send you a picture of that as well. It's quite epic.
By quote-unquote build, do you mean assembled from IKEA?
Psh, no. Made out of wood. Bits of wood that
you scrounged from the river?
Well, no. I went to a hardware store called B&Q, because I'm allowed to say their name. Other hardware stores exist. And I bought lots of decking planks and lots of other bits of wood and screws, and used my saw and a screwdriver and stuff. And
you have a tool belt that you wear?
No, I didn't have a tool belt.
What?
I had a plan in my head, and a manifest plan. I thought of it, and it happened. It turned into a giant 2.5 meter long sofa.
And did you make a blueprint, draw it down first,
No.
measurements? No, just wow.
All of the mind.
Well, as the immortal Canadian philosopher Red Green used to say, if people don't find you handsome, at least they can find you handy.
But I should be offended by that.
Well done, Kevin. Well done.
Anyway, Kevin, how are you?
I'm doing okay. How are you?
Yes, I'm well, thank you.
Good. Yeah, no, it's...
Can't wait for you guys to visit so you can try out my giant garden sofa.
Well, I just need to be able to leave the country at some point, which hopefully that day will come eventually.
Yeah.
You know, we did get, for the state of Nevada, is going to be opening up June 1st. The casinos are already putting adverts on the TV saying, come, we're open, we're going to be open. And so it's getting real. We're going to open up real soon, and which makes me very happy that STLV in August is going to happen. Fingers crossed that we can get everyone borders opened up, because Kevin, you need to come.
Yeah, I just don't know at this point whether it's going to happen here or not.
It's interesting about casinos opening up, because you'd think a lot of the games you play in casinos requires multiple people to touch the same things. And obviously, contacts are, what am I trying to say? With lots of people that potentially been infected and touching things, then the risk of infection is much higher. Like casino chips, playing cards, dice. It's going to be crazy.
It is.
Hopefully, a good state of Nevada will keep everybody safe.
Yes.
Shall we check the communication array to see if we have any comments from our listeners?
Logs accessed.
So, regarding our interview that we did with the fantastic Amanda McBroom, Stuart McElwain says, Measure of a Man is one of my all-time favorite episodes.
I said, well, we hope you enjoyed the interview.
And Stuart said, I'm looking forward to listening to it for sure. I've no doubt that it will be a great interview with large smiley face emojis. And it was. We had a great time talking to Amanda. She was wonderful.
She was just so easy to talk to and put us out our ease. because I always get a little bit nervous when we're interviewing famous people, and I think maybe Amanda's the most famous person we've spoken to, given the fact that she wrote like the song. Do you know what? I was weirdly interested and looked up an estimate of the royalties for The Rose, and like just on like iTunes, like it gets like 1 million plays a month, which is like $10,000 just on one streaming service. So yeah, that mortgage.
She said it was paying her mortgage.
Yeah, it's long.
She could have a very large house.
A mansion, like, probably. So yeah, thanks for that, Stuart. I hope you have listened to the interview since you commented and have enjoyed it. We got another comment from William Smith to say that she wrote one of the most famous songs of all time. Didn't she just, William? Like, nobody. I will go into school on Monday because we're back after our holidays and tell my students that I interviewed the woman that wrote The Rose, and they'll be like, who? What?
Yeah. What's the
what?
Rose?
And I'll be like, oh, you guys are so dumb. Stupid.
And then you will sing for them.
No.
Yes.
They just stare at me blankly.
You wheel a piano into your science lab.
I've got a piano. I've got a digital piano in my lab.
Yeah.
Well, then you have no excuse.
I'm cool that way. And it's such an easy tune to play. It's literally just 3 chords.
It is. That was one of my first songs.
That's
That's
why Amy can play it.
Hey.
So is Amy.
Hey, so Greg Molumby writes, great interview. She has such a great personality, and it was just a ton of fun to listen to. I'm listening to some of her music now, and I didn't know she collaborated with Vince Gill for The Rose. I'm listening to it now, and it's really, really nice. I'm happy you all got an opportunity to interview her. Well, thank you, Greg. It just was a great find. So glad that we had the chance to interview her and that she was willing, because she was just wonderful.
Thanks to Amy for reaching out to Amanda to organise it. Well done. Good find.
And Axel M. Björk said he was listening right now. Great interview. And then after he finished, he commented again, just to repeat myself, great interview. What a charming and awesome woman. And you guys had such great chemistry. Love this podcast.
Oh, that's so nice. Thanks, Axel.
Yeah.
Thank you, Axel. And we did Google how to say your surname, and I hope Kevin got it right. Please tell us where you're from. We think you're from somewhere in Scandinavia, or your name at least is. Please tell us, because we're curious.
This is the captain. Senior officers will report to my ready room immediately.
To get on to the crux of why we're here today, we're going to bring back a topic that we talked quite a lot about in our old podcast, whose name is like Voldemort. Now, we're not allowed to actually say it. Or if any listeners came over from when we recorded Earl Grey, you will have known we did a Science and TNG series, where we basically went through the seasons and I highlighted some of the sciencey topics that come up in the episodes, and then spoke about what we know about the current modern day science in 2020, 2021. I think with this episode of Science and TNG, we're going to do it as a round table, and we're going to highlight our favourite moments of science, or STEM specifically, because we want to include technology, engineering and mathematics, because Amy would get angry if we didn't. And I will try and pick up what we know about them. And if I don't know them, then I'll Google it and quickly come up with an opinion. I also wanted to mention that you can go back to and listen to our interview with Erin McDonald, which I'm going to highlight another network and another podcast, Trek FM's Earl Grey, the interview we did with Erin McDonald. Erin is an astrophysicist and aerospace engineer, and also currently a science consultant for the Star Trek franchise. But she wouldn't tell us what she was consulting on. I figured it must have been Discovery.
Yeah.
Have I seen her in the credits since?
Erin McDonald, she has served as the science advisor for the Star Trek franchise since 2019, and her name appears in the end credits of a Star Trek Discovery Season 3 episode as a technical consultant.
Cool. So can we quickly just go round the table? Amy, we'll start with you.
Okay.
When you think about TNG, what about the science in that did you enjoy? Or when you were first watching it, did the science jump out at you and grasp you and make you enjoy it more?
Well, one thing that I've always enjoyed, and there's actually a lot of episodes where they have this atmosphere and it's either highly polluted or it's dissipating, like talking about the air, which is very important and relevant issue to what we are dealing with the earth, with our greenhouse effects and with what's going on with our climate and environment. So I wanted to ask, like, in Matter of Time, that's the one with Rasmussen, who comes from the past future,
Berlinghoff.
But
yep.
The B plot, I guess you will, is the Enterprise is needing to save Panthara 4 from this dust storm that has caused like this holocaustic destruction on their planet. And so the Enterprise is trying to figure out, okay, how can we clear this dust storm? How can we clean their atmosphere? And that just got me thinking, and I love the special effects that they use. So that got me thinking, if you, Joe, as a teacher, as you are, how could you show gaseous, either pollution or something, and then insert some other substance to clean the air? Like, how could you visually, what substances would you be using to show dirty air and then getting clean? Is there some experiment or some gas that is like that?
That's a very good question. I suppose it's more of a chemistry question, isn't it? It might not be something that I would normally deal with in class. However, I suppose the broader point about how would you clean up some atmospheric contaminant, you would have to ask yourself first, what is the atmospheric contaminant and what has caused it? So you deal with the source, you eliminate the source, and then you deal with cleaning up whatever's left in the atmosphere. If that's, I don't know, say a biological contaminant, can you use some kind of ultraviolet or gamma rays to kind of kill it? That's a potential. If it is some kind of chemical contaminant, can you disperse something into the atmosphere that can bond to the contaminant and render it neutral? However,
so in that scenario, before you move on, would you need the same number of molecules? I'm not sure the terminology. Would you need the same number of the cleaning agent as is polluted? Do you think that you would have to calculate that and then make sure that you have enough of that substance?
Yeah, I suppose you would. I suppose it depends on the way the reaction was going to happen. Is it a one-on-one kind of thing? Does one molecule of your cleaning agent react with one molecule of your contaminant and neutralize each other? Then you've got the question of dispersal. If it's evenly distributed throughout the whole atmosphere, how do you distribute your contaminant, your cleaning agent throughout the whole atmosphere? And then other thing to think about is what is created after the cleanup process. What is the effect on the ecology of the earth, on humans? Yeah,
like what would be the
animals?
byproduct?
Yes, yeah. What happens? Like, those little plastic beads they put in cleaning, face scrubs and things like that. Those micropolymers. And they found micropolymers in the cells of marine life. Because like they get washed down through the sewers into the sea, and then fish will consume them. These just little beads of plastic. So they're finding lots of these little beads of plastic inside marine life. And then, so obviously that's potentially not very good for the marine life. But what happens then when we catch the fish to eat it? We're then consuming the little microbeads of plastic. So, and we don't really know about the overall effects of consuming all this plastic. Can be good for you. I know there was studies done way back in the 70s and 80s of we call it cling film, saran wrap. You know, like the plastic kitchen film that you wrap sandwiches in.
Oh, yeah.
Yeah.
Yep.
Apparently they had to change the ingredients of it, or the way the polymer was created, because they found that if they did a study on rats and they fed rats cheese over a period of time, some of the rats were fed cheese not wrapped in the cling film, and other rats were fed with the cheese that was all wrapped and unwrapped, and a lot of the rats developed cancer from the cheese that was wrapped in the cling film. So they thought there must have been a chemical compound leaching, a carcinogenic chemical compound leaching from the cling film into the cheese that was then affecting the rats. So polymers and plastics are very good things at what they do. They last a very long time. But
then on the bad, they last a very long time.
Yes, single-use plastics are very bad. Now the thing of packaging for food that you just bin and it goes in landfill or it ends up in the sea, or the rings, the plastic rings that go around beer cans that kind of tie up animals and choke seals to death and things like that. So yeah.
So another question with the atmosphere, like in Homeward, Baral 2, the planet Baral 2, they had to be evacuated because their atmosphere was dissipating. So again, I'm just interested in how you would show that in a classroom. What gases would you use to show a dissipation? And then a follow-up question, like, how do you think we could contain an atmosphere if that barrier was naturally decreasing?
Okay,
or deteriorating?
Okay, I have an answer for this. The Earth's atmosphere, is a very thin layer of gases, kind of from the Earth's surface out to the limits, and it doesn't get to a point and stop. It kind of tapers off into nothing, where the particle density kind of trails off to zero. I suppose you could draw a graph of like particle density at the surface is very high, and then it tapers off to zero at when you get to a very high altitude. It's gravitationally bound to the Earth, so the Earth's kind of keeping the atmosphere around it.
Oh, I didn't know that. Okay.
Yeah, so it's got mass, and it just wants to fall down towards the centre of the Earth, so it's all to do with gravity. However, if you look at Mars, there's a theory that Mars lost its atmosphere, potentially because the magnetic field around it that was deflecting cosmic radiation from the sun dissipated in some way. So what happens, I want you to imagine the magnetic field around a bar magnet. Now you got your rectangular magnet, and then you can visualize those big hoops coming around it. The Earth is
that would be, we could graph that mathematically in polar graphs with the cardioid. Yep, polar graphs, and that would be the math behind that. Oh,
interesting. I didn't know this. This is new information. The Earth's core has a giant, it's mostly iron and nickel, and it's molten and it's rotating. Okay, iron's ferromagnetic, and when you get a ferromagnetic material that starts to move, you get electrical currents set up in it, and when you get electrical currents, you get magnetic fields produced, and these magnetic fields, being really large, encompass the Earth, and so there's a giant magnetic shield around the Earth that causes dangerous solar winds to be deflected around the Earth and away out into space. If the core was to, say, cool down and solidify, then all these currents would stop, the magnetic field would collapse, and then the solar wind from the sun would literally blast the surface of the Earth. It would vaporize the oceans, like what started to happen in Star Trek 4. The atmosphere would be blown off into space, and the Earth would be left as a cold, dead, lifeless, not cold, hot, dead, lifeless lump of rock in space.
So is that the theory that's working on what happened to Mars with its atmosphere?
Yeah, I suppose we haven't looked at I certainly don't know of any science that's looked at the internal kind of geological structure of Mars. We've not dug deep down enough to be able to tell what's going on at the centre. But that's certainly a theory that something happened to Mars's core. The magnetic field collapsed and the surface got blasted with all this radiation from the sun. So how would you... I was just going to address your question about how you would demonstrate that in the classroom. I don't know is the answer. Could you simply do this as... that? Do you know when you put dry ice in water, you get all the white smoke being produced, which is just carbon dioxide gas. You could imagine the surface of the liquid is the Earth's surface, the carbon dioxide gas is the atmosphere, and a bit of paper or a bit of cardboard is the magnetic field, and then you blow a hairdryer on it, and the air from the hairdryer is the solar radiation that gets deflected around the cardboard. But if you take the cardboard away, the hairdryer blows all the smoke away, and that's blowing Earth's atmosphere away, potentially.
I like that experiment. That would be so awesome.
Super simplistic, but sometimes the simple things work.
Yeah.
You had a follow-up?
Yeah, but I forgot because I was so intrigued with your classroom demonstration. Oh, so you were talking about the electromagnetic around the Earth.
Yep.
So when you were describing that, I'm like, well, that's like shields and deflectors. Like,
is it? No, is it actually a deflector?
Yeah, could we harness some kind of molten to create a magnetic field around a spaceship, for example?
I suppose you would want it to be really strong and really, really powerful. And it's called the magnetosphere. Yeah, it's like that. Now you get the stratosphere and the thermosphere, all these layers of the atmosphere. So the very limits, you've got the magnetosphere. It's diffuse enough. It's not got a lot of field strength. So things can pass through it. Like asteroids can pass through it, or meteors can pass through it. Spaceships and probes can pass through it fairly easily. What it does do is deflect individual charged particles. So let's say a highly energetic proton being thrown out the sun as part of a coronal mass ejection or a solar flare. It's travelling at very high velocities. It's got a charge on it, so it can be deflected by this magnetic field. And so the charged particle basically follows the magnetic field line around, kind of over the north or under the South Pole, and out into space. Now, what can sometimes happen is these charged particles get trapped in the magnetic field lines, and they follow the magnetic field lines down to the poles. And when they do that, you get charged particles hitting the high atmosphere. And when you get high energy particles hitting stationary particles in the atmosphere, you get energy being released in the form of light. And so you get the northern and the southern lights.
Awesome.
Or the Aurora Australis and the Aurora Borealis, as they're known in the Latin. Just showing off that I speak Latin a little bit. So yeah.
And beautiful they are too.
Oh, have you seen them?
Oh yeah, we get them here.
Oh.
When you're out camping on a dark night and waves of green light go across the sky, it's beautiful.
That is.
Sometimes you can hear it.
Wow,
oh, really?
That's definitely a bucket list place for me. Got it.
You need to go further north if you want to see the really spectacular views of it, but it does happen here occasionally.
I think there was I can't remember when it was, mid-20th century. There was a large coronal mass ejection from the sun that impacted North America. And did it not wipe out the entire Canadian national grid? Like, it basically called that...
Like the energy grid?
Yeah, like the electrical grid. It was caused a geomagnetic storm which shorted out a lot of the grid.
I know it affects cellular communication and microwave transmissions,
Yeah.
which are a big deal in this country because the country's so huge. To beam things across the country, microwave transmissions are used quite a bit, and a lot of satellite communication too. And I know that kind of thing gets knocked out by those kinds of events.
Okay, so I just googled it. It was March 13th, 1989, and the entire province of Quebec in Canada suffered an electrical blackout caused by a coronal mass ejection. And that's basically a chunk of material gets thrown off the surface of the sun. That's very cool. So, Kevin, do you have anything sciencey? That was, please make it a short question.
So I was thinking about how in our present day and time, we were pretty amazed that the vaccines for the current pandemic that we're in got created so quickly. And yet there have been times on Star Trek when Dr. Crusher by herself in her lab just creates a vaccine. And I wonder if how that kind of biological science on Star Trek affects how people think about how vaccines work. Do you know what I'm saying?
Because they make it look like, oh, anyone can just create a vaccine. Oh, I've identified the problem. Now here's the solution. Let's execute it and save the day.
Exactly. I guess they are also dealing with science fiction concepts like replicators, and so they can instantly make billions of doses of this stuff, whereas we've got to grow it in a lab, right? So it takes us a lot longer. But
well, and I think, like, how does that social and cultural ideal of, oh, I can create a vaccine fast or translate into real life of, okay, this is taking years. I mean, and for the coronavirus, the vaccine, that was super, super fast. I actually read the fastest vaccine to be created previously was for the polio. And that took years. Yeah. And so for this to happen in 1.5 years is...
Oh, it hadn't even been a year when they announced they had a vaccine. It had been 6 months.
Absolutely crazy. But, like, can we expect to see vaccines being produced this quickly from here on out?
I suppose that really depends. Now, there was a bit of talk, or depending on where you frequent the interwebs, people weren't trusting this vaccine because the figure that was thrown about was it takes 10 years to produce a vaccine. Okay, so yeah, normally if there's a virus that exists and it maybe kills so many people a year, they want to try and create a vaccine. So you might be a scientist somewhere in the world that wants to try and do that. So you have to either fund it yourself or go through all the applications to get government funding or private funding, and that application for money can sometimes take years in itself. And then when you get the money, if you get the money, you have to start doing all the studies to see if it's viable to make a vaccine. Do you understand the pathogen sufficiently in order to create a vaccine against it? Then once you try and make it, which might take years, then you have to trial it. Does it work? Can you get a big enough group of people to volunteer their services to potentially, they could die because they could have an adverse reaction to your vaccine. So again, that process of getting it approved for public use by all the governments around the world. You guys use the FDA in the US. We use somebody, I can't remember what the UK government use. Some government organisation, Canada will use another organisation. Each country has to approve it for their own populace to use. Again, that will take years to do. So that's why vaccines typically take that length of time. However, with the SARS-CoV-2 virus that causes COVID-19, it's a type of coronavirus, the fact that it was an emerging disease that was quickly spreading throughout the world and killing people, regardless of what percentage of the population it killed, it was quite small. the fact that governments realised and health organisations realised that it was a deadly virus that was quickly spreading, that had the potential to kill many hundreds of millions. Then science basically dropped down the tools, and scientists from all around the world decided to all work together, put all their resources into working together. Volunteers did the same, to volunteer to take the new vaccines, and governments and health organisations decided to throw money at it. So all the barriers that would have otherwise been in place from a normal vaccine producing process weren't there. It was literally, we have to do this. So money wasn't a question. Time was an issue because we didn't have it because people were dying. And volunteers and manpower weren't an issue. Literally, it's one of these times where everybody in the world came together for a common purpose to try and get rid of that. And I think we're in a really good position that not many millions or more people have died. So when you look at the rankings of like viruses, viral plagues throughout history, like polio and HIV, Hanta virus, and I'm going to name something that's probably fictitious, Ebola. Those kind of really horrible diseases that kill millions of people. The flu is one that comes up every year, kills millions of people. Coronavirus is very low down in that because we've done what needs to be done.
You know, that was definitely the silver lining when I think about the coronavirus and seeing the scientific and medical community just all come together, like you said, and the government's throwing money, that we have this world problem. And as a world, we got a solution. Like, how inspirational and how optimistic I feel that, yeah, maybe if we can get together as a Earth community and not this government and centralized and we're just going to help ourselves. I was listening to another podcast that was debating whether there should be, copyright's not the right word, but
yeah,
starts with a P.
Intellectual property.
Patent.
Yeah, a patent. Yeah, that should the coronavirus or the vaccine have a patent for the big pharma, or should it just be free? Because it was all the world community, right? Greatest minds across everywhere. Like, should it be free, or should it still have a patent where only certain, Johnson & Johnson or the Pfizer company can make this vaccine? Then you're getting down to the politics of, well, you look at which countries are being able to distribute because they have it. You're getting the rich countries are distributing. Is that really going to solve the problem if we're getting now variants because the vaccine wasn't getting out to the world population fast enough because of the, restrictions on creating the vaccine for free?
I suppose it's big pharma that's producing it, really. You get Pfizer. Pfizer worked with the German company BioNTech. Yeah.
Oh, right.
You've got the Moderna vaccine. You've got Johnson & Johnson. You've got the AstraZeneca vaccine, which was developed in conjunction with Oxford University and other universities around about the UK and the world, I think. So yeah, they're going to want to, obviously big pharma's obviously going to want to monetize it in some way. Is that the right thing to do? I would argue no. But look at insulin that's produced. It's different in Scotland. All our prescriptions are free. If I got unwell, I don't have to pay anything towards the costs of medication or healthcare. So I know it's very different to what it's like in the US. I'm not sure what it's like in Canada.
Healthcare is free, but we do have to pay for prescriptions, but the cost of prescriptions is a lot lower than in America. And there is talk of a national drug plan. Once you turn 65, you get your medications at a very, 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 very reduced price. But people aren't going bankrupt buying insulin in Canada.
Yeah, that's just, it just seems crazy to me that you require something to keep you alive, but you can't afford it, so you can't have it.
One interesting thing I'd been reading recently, because this vaccine is so different from vaccines in the past, it's this mRNA technology. It's almost like a programmable vaccine, a programmable cell. There's word of an AIDS vaccine that might be coming because of the research they've been doing, using the same kind of mRNA technology. So, that's another disease that's been ravaging our planet for decades now. And if we can eliminate that too, that would be amazing.
Oh, okay, interesting. I know that the mRNA, interestingly, before we stopped for the holidays, I was teaching a little bit of biology, so I had to learn it all, and there was a bit about protein synthesis in cells, how proteins are made within the cells, and how your DNA basically unravels itself in a section, and then free nucleotides within the cells come up and make an mRNA strand. I'm maybe getting this wrong. They make an mRNA kind of sequence, like a gene. When Dr. Crusher sequences somebody's DNA, and you get the nucleotide sequence, and she compares to see if like they're a match. I think she did it with Shinzon and Picard, yeah, and like all the nucleotides were matching. Yeah, it's exactly like that. So you get this little section of DNA, which is not DNA, it's RNA, and it floats outside the nucleus down to a ribosome, and the ribosomes are little protein factories, and then like ticker tape, it gets fed into the ribosome, and is it something else? There's a wee molecule that brings in amino acids that fit onto it's red. There's 3 wee legs, and there's a bigger bit up top. It looks like a wee robot. I'm forgetting that detail. But then the amino acids, the code from the RNA is red, and amino acids then get brought in sequence and joined together, and the long chains of amino acids become your proteins. So the RNA thing that you're talking about there, Kevin, is a type of vaccine where they've created a synthetic version of part of the SARS-CoV-2, that virus's genetic code, so that your body has a hope to kind of read that code and recognize it for when you get infected in the future, so you're more able to deal with it. The other types of vaccines that exist for things are like where you'll get injected with a dead version of the virus that's not able to multiply. So your body, it's basically like having a boxing fight where you've chopped the arms off the other boxer. They're not able to fight back. Do you know what I mean? They're rendered, they're neutralized in a way. So your body can learn, or your immune system can learn how to deal with it without having the virus multiply and go nuts. You get similar things where it's not a dead virus, but it's like a half dead virus. It's weakened. Yeah, it's like the virus, but it's stuff's been removed from it. It's been disemboweled in some way. So it's not as virulent as it would have been if it was properly working. So yeah, that's the limits of my knowledge of biology there. So
great. Well, can I have Rhea ask a question?
Sure, yeah, on you go.
Yeah, so she's not here, listeners, but she definitely gave us some good topics. And she asks, what would actually happen if 2 vehicles collided in space where there is no gravity? I guarantee you it wouldn't be like what we see in Nemesis, but what would really happen? And I'm very curious about this too.
I'm also very curious, because see, do you know what threw me? I was kind of confident with my answer. Then Rhea threw in the bit about, I guarantee you it wouldn't be like in the movie, and I'm like, maybe I have to think about it more. So I think ultimately, imagine you're in an area of space with no gravitational fields. You're far away from a planet. You're out in deep space, and gravity is a fundamental force. The range of gravity is infinite. So there is a small gravitational attraction between you and I, Amy, just now. Yeah, because you have a mass and I have a mass.
Right.
And when you get two masses, they will gravitationally be attracted to each other. Okay?
Agreed.
Now,
yes.
we don't kind of suddenly fly towards each other just now while we're recording this, because there are other forces stopping us from doing that. You've got the gravity of the Earth attracting us down the way. You've got the friction between you and your chair. All those kind of things. So take us out into space where there's virtually no gravity and you've got two objects travelling towards each other. Just take one object. That one object, if you send it in a straight line, give it a push, it will continue in a straight line forever. Unless it interacts with something else like a planet or a moon, or
other gravity.
Yeah, anything else, anything with mass. So you've got two objects that collide together. Then I suppose it depends. Do they collide at the centre of their kind of masses? Is it a directly head-on collision? Are they both symmetrical? Is it directly head-on? Then it depends which one's heavier, which one has the most momentum, the most velocity. So
okay, so if you think about
momentums?
it, because in Nemesis, and I know because I love this movie, the scimitar, I would say, obviously has greater mass. Like it's huge, massive. Yes. However, it's the stationary one. It's the Enterprise that's coming, and it's tilted, I would say, a good 25, 30 degree.
You're right, yeah. Okay.
Yeah, so they come at it at the angle, but they're the one moving, where the scimitar is the solid one, but it's the one that has more mass.
Okay, so the law of conservation of linear momentum, assuming these are just moving along the same like a piece of string through space. So the scimitar has no momentum because it's stationary. Momentum is the product of the mass and the velocity. So large mass times zero velocity gives you zero momentum. The Enterprise D has a lesser mass, but and a smallish velocity. Say it's, I don't know, how like 10 meters per second ish. So you can do that mass times the velocity and get a value for the momentum. Okay. The conservation of linear momentum says that the momentum before a collision, the total momentum before a collision, is the same as the total momentum after the collision. Okay. So the X momentum for the Enterprise plus the zero momentum of the scimitar, if you add them together, has to equal a value after the collision. So they join together. That's
equal to X, yeah.
Yeah, going to be, because the scimitar's momentum is zero. So they joined together because they were kind of merged, weren't they? They were mushed together. And then that means that they're going to move off in the forward direction of the Enterprise, aren't they?
Right. So continue. So the scimitar will be pushed back a little, but there's still going to be some of that energy that is causing the destruction of the hulls.
Yes. So let me write out an equation for you. Okay. So I'm going to write out an equation. So you've got the velocities, the sum of velocities, the sum of the momenta before equals the sum of the momenta after. So if you know the mass, you know the velocity of the scimitar initially was zero. So that whole term is zero. You know the mass and the velocity of the Enterprise. If you know the mass of the scimitar, then you can find the velocity that they'll both do afterwards.
Which would then describe how much destruction because of that velocity.
Yeah.
The force of it. Yeah.
You could calculate the impulse, which is a quantity, which tells you the impulse is a measure of how much the momentum changes during a collision. And it's useful for making like crash helmets for bikes. Because if you It's the product of the force and the time. If you want a force, you don't want your head to get smashed in, so you want a very small force. That means you have to have that small force act over a very long time, so the impulse is less. So, because the opposite of that is to have a very big force over a very short time, which is bad, because big forces, very short time, is like a hammer blow, as opposed to me just pushing on your head.
Right, which would be more like Nemesis, big force, short amount of time, because they only had that X number of that distance between them, so they couldn't get so much.
Interesting. I wonder.
Can I ask a question?
Yes.
So, would the shape of the objects make any kind of difference? So, if one ship was long and pointy, like say a Saturn V rocket, and the other was like a Borg cube, you've got a pointy object coming into a flat surface. Is that going to change?
And I have a follow-up question, because you're saying the mass, to Kevin's point, is the mass, the center of mass, make a difference? Whereas the Enterprise, I would say the center of mass, would you say the saucer section or battle bridge area? Where would the center of mass be? And does that affect how it impacts?
All good questions. So, think about the saucer section of the Enterprise. It was the saucer section that made contact with the scimitar. So the point was, if the engines were lower down, the engines were here pushing forward and the point of contact was up here, then that's going to have the effect of kind of doing that kind of, the Enterprise would pivot around that axis. Kevin, what was your point again?
So my question was about the shape of the object.
Oh yes, shape, yeah.
A pointy rocket hitting a flat surface like a Borg cube. Would you end up with like a hole right through, or would one just push the other?
I suppose, to think about it simply, stilettos
depend on the density of the materials that the two ships.
Well, yeah, but even simpler, like stilettos or snowshoes. If you wear stilettos on the ice, you're going to fall through and drown. If you wear snowshoes, your weight is distributed across a bigger area, so the pressure's less. If you had a really pointy, kind of needle-like ship, like the Saturn V rocket, all the force is exerted on a tiny area, and so the pressure is going to be much larger, so you're more likely to be able to burrow through. That's why thumbtacks aren't big. Do you know, the bit that goes into the wall hasn't got a big area on it. It's a really pointy bit, so it's easier to push in. And the bit that you push with your thumb has the large area because you don't want it going through your thumb. So yeah.
Very good. Real life example for that.
I'm going to go with one. And it occurred to me, like windows on spaceships. Just not L cars. Just the viewing ports on the Enterprise D. Now those giant windows that they have in anybody's quarters in the observation lounge, they are big and they are transparent and they're potentially, from my viewpoint, very, very dangerous. They let through...
that's interesting you bring that up, because I've been watching a lot of space movies or real life astronaut movies, you know. Apple, not that it's real life, but what's the one on Apple TV?
Yep.
Mankind.
For All Mankind.
For All Mankind, yeah. And they were just sort of highlighting when they saw out the window, and I'm like, their window was itty bitty, tiny, small for them to see outside.
Yep.
And I was like, yeah, that would be pretty scary if I'm going up in space to have some kind of window. I don't know that I would want that.
True. So take that little window on the early space missions, tiny little viewing port, And then current windows on the International Space Station, they've got a piece of apparatus called the cupola. I hope I'm saying that right. It's basically an cupola. Okay, I have no idea. It's basically like an observation dome. It's a hexagonal kind of dome shape with multiple windows around it. And I think there's 6 windows around it. And they're kind of smallish windows, kind of about, I don't know, 1.5 foot across, 1 foot tall maybe. But they're made of 4 sheets of the strongest bulletproof glass that you can get, 4 very thick sheets, so that if micrometeoroids impact, then all the glass isn't going to break and kill the people inside. But then you've got the Enterprise, which is in giant space battles with enemies with disruptors and giant space lasers and explosives, antimatter explosives. Your windows have to do a really good job of stopping radiation getting through. You want visible light to get through, but you want to stop anything else that might be that quite harmful, like ultraviolet radiation, gamma rays, microwaves, X-rays, and the types of radiation that occur quite frequently in space. So whatever material you're using, you want to be transparent to the visible, but opaque to the rest of the electromagnetic spectrum. And it occurs to me that might be quite difficult. The one thing that I found, now that our favourite material in Star Trek is transparent, I'm going to say aluminum.
Aluminium.
I know, aluminium. It's the Americans say it wrong.
Goodness, what?
Americans.
No, we say aluminum here too.
Get in the sea, people from America. Yeah. What? It's aluminium. It's even spelled aluminium. I-U-M.
Aluminum. It's spelled aluminum.
How do you spell it, Amy? Spell it.
Is it A-L-L? Yeah, A-L-U-M-I-N-U-M. Aluminum.
Oh, you've missed out the I.
It's actually spelled differently in Britain.
Ugh.
Yeah.
Oh.
It's
No, I spelled it right.
A-L-U-M-I-N-I-U-M. Aluminium.
Aluminium.
Like a lot of the other elements. Lithium, sodium, aluminium. So why would...
Oh, now I see where you're going with that.
Do you mean, why did you just for that one element miss out that one letter?
So it's easier for us to say, obviously.
Uh-huh. You threw the T in the C, and I don't know, you get rid of the king, and then you missed letters out of elements. I don't know. Yeah, transparent aluminium. There was a few years ago a material produced that they nicknamed transparent aluminum, but it was transparent to X-rays. So it looked like a sheet of aluminium, but X-rays could pass through it, which was apparently quite the novel material that we'd never made before. So I suppose it's not going to be long before we start to make more exotic materials that are like just big sheets of metal, but you can see through them, which would be quite cool.
That's exciting.
Yeah. We'll be able to make submarines that are fully transparent. That'd be cool, wouldn't it?
Yes. I mean, the glass bottom boats are already cool.
Okay, guys, let's go for some of our final thoughts. That was a really good discussion there. And all our thoughts about the science. It's been in TNG. Amy, what are your final thoughts?
You know, I absolutely love and learn so much from these science episodes. I've said it before and I will continue. I loved our discussion and how you explain things so easily. Obviously, you are a fantastic teacher.
Thank you.
As I learned a bunch of stuff, and I think I taught you a couple things too. With the math, you know. So, and appreciating and recognizing STEM is very important. And when we can do that, and now I can make even more better connections when I'm teaching math to my students. Of course, relating it to Star Trek is always a good thing.
My friend Joe told me, Yeah. Kevin, what about you?
I just think it's great that we were able to include biology in the discussion today, as well as physics and chemistry, because I think the biology seems to be a science that gets overlooked, especially on Star Trek, because it's all about space battles and things in space too. And Amy looks like she's got something important that she wants to say.
Yes. So can I just tell on a parent?
Okay.
Sure, yeah, you're editing, so you can keep it in or leave it out.
Are you sure she doesn't listen?
I am 100% sure. So I was talking to the counselor, and we're doing registration for classes next year. And one of the qualifications, the end of the year, they have to take a science CRT, a criterion reference test, a standardized test for science. And one of the parents called up the counselors and was like, well, my student doesn't have to take the science CRT because my student isn't enrolled in science class this year. The counselor pulled up the schedule. The kid is in biology. It's like the parent didn't know that biology was considered a science class. Just what is the world coming to? So I thought I would throw that in because, yeah, biology does sometimes get very left out of the sciences. Sometimes. I don't know why.
You know, I wind up my biology colleagues by describing biology as the one they just use crayons in a lot of the time. They just like to colour in diagrams of plants and cells and things. But do you know what? For 3 months this year, I taught biology to a certain level, having never learned it before myself. So it was the stuff about DNA and RNA and protein synthesis I found fascinating because it was all things I kind of recognised from watching Star Trek, but I never really knew enough about to be conversant in. So yeah, I think all science is good science. Do you mean the knowledge of science is good to have? It describes the universe that we live in. Do you mean maths is a science as well? It's the language that we use to communicate our understanding of science. So thanks to Amy for teaching me a little bit of maths in this episode. It's just fun talking about science.
Incoming transmission.
We'd love to hear your thoughts on today's show and hope you'll join the Facebook group Federation Council Chambers. You are welcome to start conversations with us or add any general Star Trek info you want to share with the group.
If you'd like to send us an email, you can email the network. No, you can email us directly at galaxyclass@ufp.earth, and we will for sure read your email on the show. And be sure to follow us on Twitter at GalaxyClassPod.
Please hit the subscribe button on Apple Podcasts or wherever you get your podcasts and leave us a star rating and written review. That helps others to find the show. You can also follow the entire network's podcasts with our master feed by searching United Federation of Podcasts. This way you won't miss any of our fine shows like All Good Things, Franchise Fatigue, Always Hold On to Arrow, General Quarters, Mickey's Marvels, Infinite Diversity, and Trek Pod. So, Amy, where can people find you when you're not calculating the mass and speed of a body in motion through the cosmos?
Well, with that fantastic equation that Joe taught me, I'll be doing that quite a bit now. You can find me here on the network where I'm hosting All Good Things with my awesome friends Ken and Patrick. I am also on Union Federation podcast, which is analyzing and discussing the Orville with Star Trek episodes. You can find me on Twitter at Miss Amy Nelson, and of course, right there in the Federation Council chambers. So, Joe, where can people find you when you are demonstrating gaseous dissipation with a hairdryer and, what was that called? Cold ice?
Dry ice.
Dry ice.
Solid carbon dioxide. It's one of those substances that sublimes. So it changes state from a solid directly into a gas without first going through the liquid state. What did gaseous dissipations? It sounded like you were describing that I'd farted or something. Anyway, when I'm not doing that, you can find me on the Federation Council Chambers. You can tweet me on the Twitter at joeyjoe77uk, or you can email me joepodcasts@gmail.com. And Kevin, where can people find you when you're not making synthetic T-cell viruses causing you and your crew members to devolve into primordial species?
I've always thought Amy might look good as some kind of bird creature.
Oh.
Feathers. I think feathers would look good on
Feathers. Okay.
But if I'm not doing that, you can find me on a couple of other podcasts I do, which include True North Nerds, a general nerdity and geekery podcast I do with some friends locally here, and also a local podcast I do about live theater, which is called Stage Whispers. And we've got another episode of that coming out shortly. You can find me on Twitter at True North Nerds and in the Federation Council chambers as well.
Priority 1 message from Starfleet coming in on secured channel.
If you'd like to help us keep all of our shows coming to you each week, you can become a patron of the network on Patreon. Visit patreon.com/UFPEarth. That's patreon.com/UFPEarth to get all the details. We have 4 different levels starting at just $1 per month, and we would appreciate any support you can give us.
We would like to recognize our executive producers, Brandon Shea Mutella, Ken Tripp, Zach Moore, and Tony Robinson. We would like to thank Zach Tripp for our opening and closing music, and Tony Robinson for our amazing artwork each and every week.
Thank you for beaming aboard the Galaxy class, and until next time,
Science!
Great joy and gratitude.
things are only impossible until they're not.
Engage.
This has been a production of MTMR Media Works.
Well, Stuart McElwain said that measure of a man is one...
Wait.
Yep.
Yeah.
Will you say where it's coming from first?
Okay.
Like
From the
the-
Amanda McBroom interview.
Oh, okay. All right.
Just introduce it so they know.
Okay.
Thanks.
So, regarding our interview with... This is my first day with my new tongue.
It's such a beautiful tongue.
Thank you. I love my new tongue. If I mispronounced it, you can email me at joepodcasts@gmail.com.
Excuse me? That's just rude. I feel very attacked right now.
I'm loving this.
It's because I've had some wine. Have fun editing this, Amy.
Oh my gosh.
No. So, mass of the Enterprise times the velocity of the Enterprise plus the mass of the Scimitar times the velocity of the Scimitar has to equal, this is before, you can edit this together so it sounds kind of coherent, the mass of the Enterprise plus the mass of the Scimitar times the velocity. I'll hold this up to the camera and see if you can make sense of it, okay? Directly behind the saucer section is roughly where the impulse engines are. And it's the impulse engines that are causing that force to carry it forward. So I suppose if the impulse engines, sorry, Cooper's crying and it's going to be picked up with the mic. Hold on. Cooper, right, you can come in if you're quiet. Right, sit down. Come on. Okay, sit. No, sit down, Cooper. Lie down. Lie on the floor. Lie down. That's a good dog. Sorry, we just picked them up from the groomers. They've all had their summer haircuts. Ah, bless.